Hi, 6th grade. Well, congratulations. You made it through physical science. Yay! I know you thought you would never ever get through physical science, but we did. We're finally through, and now we can move on to rocks and minerals. So, for you guys, rocks and minerals is a really cool thing to start looking at. I know some of you said that you've touched on it a little bit in other grades, and that's awesome. But what we're going to do is we're going to dive a little bit deeper than you did back then. We're going to talk specifically about rocks and minerals and the different types and how they're formed and what makes them up and what makes them so special and why we need them in everyday life. You guys may not realize it, but there are minerals in the food that you eat every day. You need them to survive. And so we're going to talk about some of that stuff, but specifically about the hard minerals, the things that you see outside, the gemstones maybe you wear on your jewelry, all that fun stuff. So, because there's a lot of information, we're breaking it up into two sections. We're going to do minerals first, and then we'll dive into rocks and talk about sedimentary and igneous and metamorphic and all that fun stuff. But we're going to do minerals first. So this entire to-do list is over just minerals. You're going to learn the ins and outs of all of it, and it's going to be great. You guys are going to become little mini geologists. It's going to be awesome. So let's get our notes started. As you can see, I already have the rocks and minerals units notes at the very top of my page. So make sure you guys have that written down. I also have the date today, because that's important. You need to remember, when did I take these notes? How long ago was it? And it also helps you keep them in order. So, if at any time I'm moving too fast, you guys can pause the video and catch up with me, and then we can pick up right where we go. So, you ready? Let's get started. Page 88, Properties of Minerals, Chapter 1. So, our first big blue question. What is a mineral? So, this whole section is going to be about just what on earth are minerals. So let's get started reading. Look at the two substances in Figure 1. On the left is a hard chunk of coal. On the right are beautiful quartz crystals. Both are solid materials that form beneath Earth's surface. But which is a mineral? Any ideas? Well, we're going to find out. Defining minerals. How are minerals defined? Now we see we have our blue key there, so it's going to answer our question as to what a mineral is. A mineral is a naturally occurring solid that can form by inorganic processes and that has a crystal structure in a definite chemical composition. For a substance to be a mineral, it must have all 5 of these characteristics. So that's a lot of information, I know. Let's put in our notes and then we'll break it down. So here's the way I kind of like to take my notes. I like to start with the red topics there as defining minerals. That's our big topic that all of the information we have is underneath. And then I like to put my bullets in. So first we have a mineral. So what was a mineral again? It's a naturally occurring solid that can form by inorganic processes and that has a crystal structure and a definite chemical composition. So that's a lot of information. The next thing that we read in there was that a mineral must have all 5 characteristics to be considered a mineral. So let's think for a second. Let's look at our definition. What are the 5 characteristics that it told us that it has to have? Well, one of them is that it's naturally occurring. Another is that it's a solid. Next is inorganic processes. And then there's 2 more. Crystal structure and definite chemical composition. So those are the 5 characteristics a mineral has to have to be considered a mineral. Now, on the next page in our reading, it's going to break down the 5 different characteristics. So I'm going to read a little bit from each section, but then I'm going to explain them a little bit more to you so it makes a little bit more sense. So let's start with the first one, naturally occurring. All minerals are substances that are formed by natural processes. So let's think for a minute. What does that mean? What is a natural process? Well, it's really easy to think of things that aren't formed naturally. Like, what do these different products have in common? Cars, TVs, plastic, forks and scissors and all these different things. What do they have in common? Any ideas? Well, they're all man-made. They're all made in factories. People make them, put them together, and then ships them out into the world. For something to be naturally occurring, it has to happen just on its own in nature. Somebody can't decide they're going to put it together. Someone can't decide to put 2 things together and say, oh look, a mineral! That's not how it works. It has to happen all on its own. So solid. I'm not even going to read the solid part because we just went through an entire unit about changes of state and states of matter. So you guys know that a mineral, if a mineral is a solid, it has to have 2 things. Definite shape, definite volume. You know that already. So let's move on to crystal structure. The particles of a mineral line up in a pattern that repeats over and over again. So already, a red flag should be coming up in your head here. That sounds really familiar. Where have I heard that before? So, if the particles line up in a pattern that repeats over and over again, and we know that a mineral is a solid, what type of solid has those 2 things? Well, we know that there's 2 types of solids. There's crystalline, and there's amorphous. So which one of these 2 has a repeating pattern? Crystalline. Crystalline has a repeating pattern. The repeating pattern of a mineral's particles form a solid called a crystal. So we should probably make sure to put that in our notes. So a crystal is a solid formed from the repeating pattern of a mineral's particles. That makes sense, right? Let's keep reading. A crystal has flat sides called faces that meet at sharp corners and edges and corners. So maybe we should make sure we put that in our notes too, just so we kind of remember. So, a crystal has flat sides called faces that meet at a sharp edge or corner. So I'm sure you guys are already thinking about different crystals that you've seen before, whether it's on TV or in video games. You've seen crystals that have the sharp little edges that kind of make prisms. Yeah, that's kind of what a crystal is. So let's move on to the next one. Forms by inorganic processes. Now this one's going to sound a little complicated, but we're going to break it down. All minerals must be able to form by inorganic processes. That is, every mineral must be able to form from materials that were not part of living things. So I think we should probably put that in our notes real quick. So inorganic process. It's a process in which the materials were not part of a living thing. So let's think for a second. What are some things we consider living? Well, there's wood, there are trees and plants, grass, all the stuff outside. That's all considered living. We're considered living, right? Animals are living. So for something to be inorganic or be formed by an inorganic process, that means it needs to be formed by something that's not living. So a crystal can't form from a skeleton of some sort, because the skeleton belonged to something that was once living. A mineral can't form from something like a plant or grass or a tree, because those are all living things. Those are all organic. Inorganic means not living. And let's do the last one. Definite chemical composition. A mineral has a definite chemical composition. That means that a mineral always contains certain elements in definite proportions. So as you guys remember, an element has a single kind of atom, one type of atom, that makes it unique from all the other different elements. So for something to have a definite chemical composition, that means that it can only be formed by certain chemicals every single time. Two minerals that supposedly are the same can't have different compositions. They can't be made up of different things. If they're made up of different things, well, then they're not the same thing anymore. That makes sense, right? Awesome. Let's keep moving then. Now we're going to jump back to a little bit of the chemistry we talked about not too long ago. Minerals, compounds, and elements. So I'm going to put that in my notes. Minerals, compounds, and elements. Let's read. Almost all minerals are compounds. Well, that's already right off the bat. We need to put that probably down. Almost all minerals are compounds. Let's see if it gives us some examples here. In a compound, two or more elements are combined so that the elements no longer have distinct properties. For example, the mineral cinnabar is composed of the elements sulfur and mercury. Okay, so we need to make sure we put down that example. So the element example, cinnabar. And what did we say it was formed from? Mercury and sulfur. Those are both elements that you can find on the periodic table. Sulfur is a bright yellow. Mercury is a silvery liquid at room temperature, but cinnabar is a has solid, shiny red crystals. Different minerals have a different combination of elements. For example, a crystal of quartz has 1 atom of silicon for every 2 atoms of oxygen. The ratio is consistent for all varieties of quartz. Each mineral in a garnet group of each mineral in the garnet group of minerals has 3 atoms of silicon for every 12 atoms of oxygen. But garnets also contain other elements in set ratios. Figure 2 shows one variety of garnet. Some elements occur in nature in a pure form and are not as part of a compound. Elements such as copper, silver, and gold are also minerals. So we can put that in our notes too. Some elements are also minerals. Example, let's see, what were our examples? Copper, silver, and gold. Awesome. See, here we have a picture of garnet and quartz. Now, the next part of our video is going to be minerals identified. And right now, we're not going to talk about those. In the next couple videos that you watch, we're going to break down the different ways or the different characteristics and properties that we use to identify a mineral, such as color, streak, luster. We're going to break it all down for you. But now, for right now, you are done. I'll see you on the other side, little geologists.